All right, this is section 3.9. I'm just going to do some miscellaneous problems. I'm not going to do some that are just so simple that, like number 1, you just plug those numbers in y equal mx plus b. So I'm not going to do some of those. Number 3, I will look at. They tell you have a slope of 3 because m is 3, and f of 0 is 1. Now that's a point. That's the point 0. I didn't write it right. F of 0 is 1. That's the point 0, 1. Okay. Now, here, they really did give you the y-intercept. When x is 0, that's the y-intercept. So the fastest way to do this one is to say that's just y equal mx plus b. And again, this is the same type problem that number 1 is. It just wasn't hidden as much from you there. So your slope is 3 and your y-intercept is 1. Now, if you didn't do it that way, the other way you could have done it if you didn't realize that was the y-intercept, and this would always work as well, is if your slope is 3, you could use the point slope form because you got a point to plug in. And you could have, if you didn't realize that was a y-intercept, you could have labeled that x1, y1 and put in x minus 0 and y minus 1. And you would have had y minus 1 is equal to 3, x minus 0 is x. And then you could have added 1 to both sides and got y equal 3x plus 1. But do you see how much faster it was on the left-hand side to notice that that was the y-intercept? Okay, when you get to number 9, you notice they've given you the slope, and they've given you a point, and I'm going to write the point as a point. X is 1. When I plug in 1 into the function, the y value that goes with it is 5. Well, the easiest way to do this again is to do point slope form, because you got a point and you got a slope. Okay? And that formula is y minus y1 is m minus x1. And like I told y'all, this is the one we use in calculus all the time because it's just so handy. My slope is 2, so that goes over here where the m is. This point over here, there's my x1 and my y1. I only got 1 point, so it's x sub 1, y sub 1 if we're using the correct terminology. So that's 1. And then over here, y minus y1 is 5. In case you have a hard time with this y and this x always stay in the equation. They don't get filled in with anything, okay? But anyway, there's your equation right there. You could solve it for y. You could add 5 to both sides. You might want to wait to add 5 till after you distribute so you don't confuse yourself. If the book gives it like y equals something, I would have had to distribute 2x. 2 times x is 2x, and 2 times negative 1 is negative 2 plus 5. And if they write it in slope-intercept form, it would have been 2x plus 3. So I don't know how they're going to write it, but even if they write it like this, they got it from doing that. Okay? Okay, number 15, they've given you 2 points. Okay, so you got the point 0 minus 3. And by the way, if you realize that, that's the y-intercept because x is 0. And that might save you some time. And then you got the point x is 3, y is negative 3. You got all kinds of choices here. You could either use point slope form or slope intercept form. The problem with this one is we don't know the slope. But we can find the slope pretty easily because we could say that's just subtract your y's on top, subtract your x's on bottom. Y2 minus y1 over x2 minus x1. And I'm going to make this x1, y1, x2, y2. Okay? So it would be negative 3 minus 3. I also might notice something about this one. Aren't the y values the same? Okay, so I'm doing all this work, and I'll go ahead and finish this 3 minus 0 here. But if we simplify this, negative 3 plus 3 is 0 over 3, which is 0. This is a horizontal line because it has a slope of 0. What I was noticing as I was working the problem was that if these y values are the same, we know it's a horizontal line. Because if it's a line and it goes through negative 3, 2 different points, it's got to be a horizontal line. And a horizontal line has the equation y equal whatever the y value is. Well, it's negative 3 in both of these cases. If you didn't realize that, and you tried to plug this into the point slope formula, maybe that's what you thought. You could have gone and done that. You could have said y minus, let me use y1 as negative 3. And then the slope was 0, and then x minus 0 is the x1. You would have had y plus 3 equals 0 times x. So y plus 3 equals 0, y equal negative 3. So the thing about it is even if you didn't realize it, you would eventually come up with the right answer if you just plugged it in, let's say, for instance, to the point slope formula. But the fast way to do this was go, oh, the two y values are the same. If the y is always the same, that is y equal whatever that y is all the time, which is negative 3 here, and you would have been done. Okay, so in this problem on 27, they tell you f of 6 is 7. You need to realize that's a point. X is 6, y is 7. And then they tell you f of 3 is 2. That's also a point. X is 3, y is 2. Remember, this is f of x equal a number. So whatever the x is right here, and then f of x just a shortcut for y, so you could write y equal whatever that number is on the end. But that's just what this notation is telling us. There's the x value, there's the y value. All right, if I want to find what f of negative 3 is and f of 10 is, I could try doing some things like making a table, but honestly, you're still going to have to do the same thing no matter what here. You're going to have to write an equation of a line. So if I have 2 points, how do I write an equation of a line? Well, do I have the slope? No, but I can find it because I got 2 points. So let me label my points. I'll call, just because the numbers are smaller, I'm going to call this one x1, y1, and I'm going to call this one x2, y2, just because I know I'm going to subtract, and I like my bigger numbers to be first so I don't have negatives. So my slope is going to be, I'm going to write the formula down, y2 minus y1 over x2 minus x1. You need to think, I got 2 points, I can find a slope every time you see 2 points given to you if you don't already have the slope. Alright, so let's see, I'm going to put my subtraction signs down in my fraction bar, and I'm going to fill this in. Y2 is 7, Y1 is 2, so that's 5 on top. And on the bottom, X2 is 6, and X1 is 3, 6 minus 3 is 3. So my slope is 5/3. So let me write what I'm going to do is use the point slope equation. Y minus Y1 is mx minus x1. I'm so glad this book is emphasizing this so heavily because helps when you get to calculus. My slope is 5/3, and I'm going to have my x in there and my y in there, but I need to pick a point. I'm going to pick the smaller numbers. I'm going to pick 3 and 2 here, and I actually already did have those labeled as x1 and y1, so that worked out great. X1 is, and I'll put them in red just so you can see where I'm filling it in. X1 is 3, filling that in. Now for the y1, y1 was 2. So here's my equation. Now, I got to find 2 values. I don't want to have to solve everything twice. So here, even though this is a great equation, let me solve it for y, and that way I can plug my x in, and it'll be a lot faster to work, okay? So what I'm going to do is this. I'm going to say, okay, add 2 to both sides. Probably before I did that, I should have told you to distribute first, just because I shouldn't have, I mean, you can do this. There's nothing wrong with what I'm doing here. But you got to distribute before you add 2. And a lot of people would accidentally think that they could add negative 3 and 2 together, and you really can't because PEMDAS says you got to clear up this distribution first. 5/3 times x is 5/3 x. 5/3 times negative 3, think about that. 5/3, we know a positive times a negative is a negative, but 5/3 times 3, if I threw 3 over 1, you can see those 3's are going to cancel out, and it's just going to be 5. That's great. Plus 2. So that's going to be 5/3 x. Negative 5 plus 2 is a negative 3. So now, if I want to find f of negative 3, that just means take the equation 5/3 x, this one right here. I'm just going to write it in function notation. 5/3 x minus 3. Remember, that's the same thing as y, but that's telling me to plug in negative 3. So let me put in negative 3 here. All right. The 3's are going to cancel out, and that's going to be a 1 and a 1, right? So it would be 5 times negative 1 is negative 5 over 1, which is just negative 5, minus 3 is negative 8. So f of 3 up here is negative 8, if I didn't do anything wrong. And then f of 10 would be, take that equation, 5/3, I'm using it again over here, x minus 3, but this time x is 10. Not going to be as pretty. Nothing can cancel out. If I put 10 over 1, I'm going to get 50 over 3. I'm out of room, so let me come over here. 50 over 3 When I multiply that out, minus 3, but let me multiply 3 times, get a denominator of 3. I'll multiply it by 3 over 3 so I can, have a common denominator. So it's going to be minus 9 over 3. And that's going to end up being 50 minus 9 is 41 over 3. Avoid the temptation to think you got to write that as a decimal, even if the book does it as a decimal. And I'm not looking at the book, so I don't know. Let me check. No, they don't. I've got it right here. Don't write that as a decimal. Leave it as a fraction, because you're going to be doing stuff with some of these numbers in other courses, and so you want to get used to writing it this way. Don't give decimal answers. Just reduce your fractions as far as they can go, and that's reduced as far as it can go.